In Appalachia, we've got a lot of coal mines. Some of them are being retired, but in any event, all of them require remediation and they create waste. And I'm talking about a lot of waste. Question is, can this waste be worth something?
Paul Zimkevich is standing in front of a silo full of crushed limestone that slowly gets flushed into a stream pouring out of an old coal mine here. It's a state-of-the-art, state-operated facility that treats acid mine drainage. If it weren't here, the stream would run rusty red, killing ecosystems in its path.
So we're at the Omega Mine, and the Omega Mine is about 4.5 miles south of Morgantown, West Virginia. And it's an area that's been heavily mined for coal since the Civil War.
This year, Zimkevich, the director of the West Virginia Water Research Institute at West Virginia University, was awarded $2.6 million federal dollars plus funds from the private sector. His research aims to locate, isolate, and commercialize select hard-to-gather elements of the periodic table, elements that are critical to the technology age we live in. Some of those elements can be found in acid mine drainage.
I finished up some calculations that the acid mine drainage production in West Virginia, Pennsylvania, Maryland, Eastern Ohio can supply anywhere between, and this is in terms of rare earth, somewhere between 800 tons per year to maybe 2,200 tons per year. Now, 800 tons a year is basically what the military needs.
Zimkevich and a handful of other scientists in and around the Ohio Valley make up the majority of the American team dedicated to cracking the rare earth element puzzle. That is, the team that's on the hunt for rare earth elements and how to build an industry around them. The Americans are the underdogs. Right now, China is the team to beat, where 95% of the rare earths used in phones, electric cars, and smart bombs are all sourced.
In 2011, the prices of rare earth elements spiked, in part because of the supply problem from China. And so that instilled an interest in researching other sources of rare earth elements throughout the world, but also in the United States.
Tom Tarka is the technical project lead for rare earth elements at the National Energy and Technology Laboratory in West Virginia. He explains about 140,000 tons of rare earth elements are processed globally each year into products on the market. So far, there's no commercially viable alternative for sourcing these elements outside of China, since the U.S. doesn't want to have to rely on any single other nation to provide important components critical to national security. Government funds are funneling into research at the National Lab in Morgantown, which largely focuses on coal and fossil fuel research. Marianne Alvin is the head of the Rare Earths Division there.
Right now what we have is actively 15 programs, 15 projects that are investigating not only separations, investigating where we can find our best reserves, and how can we take this forward.
Rare earth mines have tried and failed in the U.S. already. They just weren't profitable on their own. The hope now is that rare earth mining can be economically viable if it piggybacks on other mining operations, like coal. Researchers have already begun to identify rare earth elements in and around coal seams, as well as those within waste products associated with mining and burning coal.
Turns out that in Appalachian coals, especially southern West Virginia and central App, we're seeing more heavy rare earth elements. And that's good because these heavy rare earth elements they're rarer, and they have an increased value as a result.
So it turns out rare earths are not actually rare so much as rarely concentrated. They are hard to extract. It usually takes acids and harsh chemical processes, which creates the stuff of environmental nightmares. West Virginia is already coping with environmental nightmares.
Before the Clean Water Act, the Monongahela River at Morgantown was orange, and it had a pH of about 4.2. It was absolutely dead. The only difference between then and now is the amount of treatment that water gets before it winds up in the river. So the Clean Water Act required companies to treat a lot of that acid mine drainage. And right now in the Mon River Basin, I think something like a third of all the acid mine drainage is actually being treated in industrial size operations.
So acids are literally seeping from coal mines everywhere throughout Appalachia and apparently leaching rare earth elements in the process.
It turns out that the more acid seams give us the best results because it has the most pyrite. Pyrite in turn generates the acid that leaches the rare earths out of the rock.
Simkevich's research is not only identifying which elements exist in acid mine drainage and the sludge left from treatment of polluted water, but also how to process the elements and get them into marketable form.
Rather than sludge disposal being a liability, if you could actually make some money on it, and it's probably not going to pay for all of the costs of AMD treatment, but even if it knocks down the cost by 20, 30, 40%, that's a very, very significant incentive to continue treating acid mine drainage.
And Simkevich is just one researcher. Others in Kentucky and Pennsylvania are studying lots of other coal waste products. Scientists estimate that with continued research, a rare earths industry is 10 to 20 years down the road. For the legislature today, I'm Glynis Board.